Welcome back to my channel. I am here back with another binary search playlist question, and today we will solve to how to implement a lower bound. So in this question we would given a sorted array and an integer x, and we have to find the lower bound of x. So what does a lower bound critically means? The lower bound critically means that we have to find the first and the smallest index in a sorted array where value at that index is greater than or equal to a given key x. Means in a simpler terms, if we have to write it, so we can say that here that the lower bound is the smallest element which is greater than or equal to x. So let us see it by an example. So we are given with an array of 1, 2, 2, 3. Now here 2 is present, so we can clearly say that 2 is already present in the array. So the output is 1 because 2 is greater than, not greater than, it is equal to 2. So we have returned the first index in the sorted array were greater than or equal to given key x. So this question in a brute force way can be solved by a linear search in which we can traverse every element and we can check if that element is greater than equal to x or not, and we can return that index. But we are clearly given here that it is in sorted array, so we need to think if the array is sorted we can apply a binary search here. So we will do that only, that we will solve this question by applying the binary search algorithm. So I have took an example here. We will solve this question by taking an example. So assume that we have given with this array 3, 5, 8, 15 and 19, and there is a target element for which we have to find the lower bound. So we would take the low as on the 0th pointer, the high on n minus 1. If you have not seen the previous video, please check it out. So we would always place the low element at the starting of the array, and we would always place the high at the last index. Now we will find the mid element. How to find the mid element? We can find the mid element by taking low index 0 plus the high index 4, which is equal to 4, and divided by 2, which clearly gives 2. So mid would be placed at 2. Now we need to check that if the middle element is greater than or equal to x or not. So we can clearly see that the 8 is not greater than 9, which means that the left search space would also contain all the elements which would be lesser than 8. So we can say that the lower bound is not in the left search space. So we can eliminate the left search space by taking the low to mid plus 1. So we will place the low at mid plus 1, and we would again find our middle element. So we would find our middle element, which is equal to 3 plus 4, which gives 7, divided by 2, which gives 3. And we would place our middle element at the third index. Now we would check that if the middle element is greater than or equal to x, so we can clearly say that 15 is greater than 9. So we can say that our answer would be at this index, third index. But we need to find, as stated in the question, we need to find the smallest index. So if we need to find the smallest index, we would go here we would trim down our search page to left because we need to find the smallest. So we would place our high at mid minus 1. So at this point we can clearly say that the high crosses low, which means the search page had ended. So we can say that our index answer would be 3. So this means that the element which is greater than or equal to, which means the lower bound of 9 would be 15. So we would quickly code this up. So guys, we will quickly code this up, the solution, and I am doing here the solution on code 360 by coding ninja. You can also try the same. So one edge case I need to define here, that it is given in the question that if all the numbers are smaller than x, then n should be the lower bound. So if any element which is not greater than or equal to the x is present, so we can return the size of the array. So we can say that if a lower bound is not present, then we can return the size of the array. We would take the low at the 0th index, we would take the high at the last index, and we would apply our binary search, and this while loop, this condition checks that if low does not crosses the high. Now we will calculate the middle element, which is equal to low plus high divided by 2. So the first condition, we need to check that if the middle element is greater than equal to x or not. If this condition is satisfied, then we can say that our answer is the middle index, and we need to trim down the search space to mid minus 1, because we need to find the smallest index. And else, if this condition is not satisfied, then we can say that our lower bound is not present in the right search space, and at last we can return the answer. So this is the solution. Let us run this. All the test cases pass, and you need to submit the code. So this is done. So this is the solution for the lower bound. Hope you have liked it and hope you have understood the question. Please solve and take care.